Welcome to the Machine Learning at Home. Today I will speak about random forest, extremely efficient, powerful method of machine learning. So let me do it practically. We'll go and I will explain what is going on. So let us first load the library for random forest. But before we do it, many of you probably need to install it. So your first step will be install packages, and name of the package you want to install is random forest. So look like first letter is R lowercase, whereas middle F is uppercase. It's important. But in my case, this package already installed on my system. So while you guys are waiting for the end of installation, just I need to remind you that if R will ask you about mirror, use the first one. If R will ask you about location of the package, use the default one. So then we can load it with the next command. So everybody will need to do it, me and everybody. Library random forest. Okay, so if the package was installed, then you will see something like this message. Now we need to run the model on the same iris data. So I will create training subset from the initial iris data, square brackets for selection, comma separate rows from columns. I will work with rows, and I will do it slightly different way, but it's very essentially similar to what we did before. So C is a vector command to concatenate, and then RP to repeat. I will repeat 0 4 times, and will also add 1 to it. And then I will compare with 0, which will have result true for 1 and false for 0. So it will be 4 falses and 1 true. So it simply save a bit of typing, nothing more. And then testing will be done the same way, but with exclamation mark for negation. Now we need to run the random forest. The same name of the function as the same name as the package. So very similar interface based on formula approach. Species against dot for all 4 other characters. Data will be iris train. And we need to save it into some new R object. So iris dot rf, for example. Okay. Now we need to look what is iris dot rf. If you remember, these objects are very different in LZA and CART card, right? So what is here? Oh, this is interesting. So it will provide you with some confusion matrix, not extremely useful because it's only deal with our training subset. But look in the center. It has important phrase, number of trees. So random forest runs classification and regression trees 500 times by default, and then will give you results of these multiple runs. Of course, it's almost absolutely useless to run it on the same data, so R will use bootstrap. So random forest will bootstrap the data set, which means that rows will be shuffled, plus, important, some rows will be removed and replace it with other rows. So some rows will appear several times now. So each time data will be changed that way, and classification and regression trees will be run on a changed data. In the end, all results will be sophisticatedly summarized. So this is what random forest is. So it has pluses of both LZA and CART, because LZA gives you lots of numerical output, which CART is unable to give, because CART is very binary method. CART is easy to overfit, whereas LZA is not, and random forest is very hard to overfit, overtrain. So this is a very good plus. It's also very omnivorous. It can take any kind of data, so it has very little restrictions, similar to CART, whereas LZA is simply decorated with restrictions, lots of restrictions for LZA. So many good things about random forest. It's also very fast. You see 500 trees run like in less than a second. Now we go to the prediction. So we'll use the same predict function and use iris.rf, our model. And then for new data, use iris test. Of course, without character number 5. And of course, save everything into iris. For example, RFPRED. All right. So, this is a letter E. Okay, now seems like everything is good. And now what is iris.rf.pred? It's simply class labels. We can go straight to our misclassification table. So we say table iris test. We need that omitted column number 5 against our predictions. RED. Okay, so looks like it's good enough. So only 8 irises were misclassified. Results are comparable with CART and with LZA. So now, like, we can go slightly further and explore interesting features of random forest, both positive and some negative as well. So very positive feature is that random forest will provide you with variable importance like CART. So you very simply can access it. So like a function is importance. And that should be applied to model, not to prediction, to model. Iris RF. So by default, it will give you the Gini decrease. Gini, if you remember something from economical papers, is a coefficient of inequality. So in that case, inequality means that when data is split in CART, the best way is not to mix 2 different classes together. So the more unequal is split, the better. In that case, petal length is extremely nice. It is character which allows you to split species very well without almost any other species present in a group of 1 species. So it will be very clean split with petal length. Next one is petal width, and then to other characters. So this data, by the way, are not really contradict with what we already know from LZA. All right. So, and next interesting feature is that random forest allows you to obtain the probability of class belongings. So again, it is similar to LZA, and by the way, CART does not allow you to do it in a proper way. So for that reason, we need to make slightly different prediction. So we'll repeat the previous one, but I make this prediction object number 2, and also will add additional option type equal to prop from probability. So now the pred2 object will contain probabilities of class belongings, which will allow us to understand which class is predicted better for which object, for which row. For example, if you remember, we use that probability in LZA for rows from 60s to 70s. So let us do it here as well. Iris RF pred2, and then we need like specify rows from row number 60 to row number 70. Okay, so look, for example, in row number 86, it has like 59% of probability to be versicolor, 31% to be virginica, and even 10% to be setosa. So kind of very in-between object. What are negatives of random forest? First of them is theoretical. because like both LZA and CART allow you to explain model exactly. For example, in LZA we can always say which of characters with which coefficient made which linear discriminant. So linear discriminant are simply linear combinations of initial characters. In CART, we can always say on the first step we use that and that character. On the second step, that character, and this is how we split our model in the second step. Unfortunately, random forest is a bit of black box. It works well, but does not allow you to tell how exactly. So this is one of minuses of random forest. Another one is that random forest is a bit stochastic method. Look, I will repeat some of our prediction processes. So I will make our model again second time. Then I will make a first prediction again. Then I will repeat my table again. Okay, and it's by the way the same, but I will make it next time. Oop. And now again, table. Okay, this is what I wanted to show you. Look here, these two tables are slightly different. For example, there are 3 Virginica in the first table and 2 Virginica misclassified in the second table. So second is slightly better. So what is going on? Each time random forest use 500 bootstrap replications, and these replications are random, so name is random forest. So it make many trees, that's why forest, in a slightly random way. So results are not exactly stable. So many people dislike this feature of random forest, kind of instability. Not exactly great instability, because you see the difference is very small, but instability, yes, it is present. So these are pluses. I would say that pluses are our way, like all minuses of random forest, of a great popular method of machine learning, random forest. Thank you very much.